Okay, so this is really like everything I can give you. Like as long as you understand like the breakdown of the meaning of the large language models, it's good. All right. When it comes to like applying the model for business values. Okay, so the first word is models. So when you see the word model, model means a function f. You learned in like middle school and high school, right? You get an input, you get an output. Input changed to output through that function. Period. Done. Right? Next thing, input. The word language means like the input of the model or the function f is a sequence of one or more words. Okay, so that's why we have the word language in the name of the large language models. Then finally, it says large, but this is very ambiguous because like back in 2021, BERT was was considered as like a large language model, but now it's tiny language model. So the word large, the meaning of the word large changes over time. Now when we say like a large, maybe like a GPT-4, would it be large? And yeah, but BERT is obviously very small model now. Okay. And then I discussed about the generative AI lifecycle, but I want to add one thing here based on recent discoveries. So between thinking about the scope of the project and selecting the model, what's actually really important is like what do you really have a quality for your training data? Because like remember, every data science project starts with the principle garbage in, garbage out. So make sure your data is having some like a good quality, right? And another evidence you can find about this data quality is like, have you heard about the model Phi1, Phi2 from Microsoft? So this is a 1 trillion or 2 trillion parameter model, which is very, very small compared to Llama 2. Llama 2 has like a 7 billion. That is the smallest size of Llama 2 model. But with the textbook quality data, they do better than other like open source LLMs. So data quality really matters, right? So check your data. And then I want to highlight the later stage of the life cycle because I think like most of you are like software developers and engineers, right? Your knowledge and your skills can be leveraged in this like a late stage. Like, oh, I don't know mathematics, I don't know like deep like computer science theories or something. It's okay because there's so much value in this like a later stage of the life cycle, right? So I thought about like, okay, let's go over like a big stuff that came out like the past 2 years. But then like there's so many things to discuss. And if I, for example, if I choose like a LoRa, I can literally talk about this for an hour. And I don't want to go over time like last time. And I think like the time I overrun like last time really like roll over. So I want to go quick this time. So I thought about it. And then I was like, okay, I'm moving to Atlanta like tomorrow. Then I'm not sure like whether I come back next time. So like, I assume like this be the last presentation. Then what would it be the most important message I can deliver to you, right? So presentation part 2 is actually join me, right? So here's the agenda. So I'm going to go over the AI industry overview to persuade that like it's really the good time to jump into this AI industry and AI field. And then we will have a break because the second part of the presentation is for the people who want to do like research in AI. So that I'll introduce like what would be the basic baby steps before you actually do some research on AI. And then I'll discuss like how to study AI from archive paper because there's not many good textbooks in AI. Like at one point, you have to go to archive and read a paper. So I'll introduce like how I study like AI when we get like a new, fresh, hot like archive paper coming out. Then I'll also add some like resources for those people. Right, so let me start to persuade you with numbers. So this is from Bloomberg, and they project the revenues from generative AI to increase by $1.2 trillion until 2032. And you see like a 2023 last year was only $67 billion revenue, but it increased like exponentially. And when you see the generative AI as percentage of total technology spent, it also goes up. So there are many, many opportunities coming in because like it's not the end. Like GPT-4, okay, come on. GPT-4 is there, but you need users to generate values out of it, right? Second one, okay, then what about that? Like you see like NVIDIA, AMD stock prices are like a skyrocketing. You check like Robinhood every day and it changes numbers like so good. Okay, so all right, that's a really good stories. Okay, then let's check like what about the software? Software is like where we work for, right? So when you see the Bloomberg's like intelligence like numbers, the compound annual growth rate in hardware between 2022 and 2027 is only 42.6%, but when you see the software, it's actually doubling every year on average. And even after they slow down a little bit, the growth for software is actually doubles the hardware. So there are more opportunities in like a usage of LLM versus hardware that runs the LLM. Good? So if you're not persuaded, why? Right? When I talk to people, they feel like, oh, AI is too complicated. I don't really understand the transformer architecture. I don't really understand how the how the model generates words or something like that. I don't know causal training. I don't know masked language modeling, blah, 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 so many terminologies. Okay, then let me give you some analogy to auto industry, all right? So when you see the car, you have engine, you have glass, you have tires and wheels, body material and design, and emission. There's so many different components to understand to manufacture and maintain the car, right? When you see the auto industry, you have engineers and scientists who try to like improve the efficiency of the car, and mechanics who fix the car when there's a problem, and you also have like auto workers who actually like build it, right? But are they pretty much like all the people working in the auto industry? Maybe not, right? And when we see the car alone, passenger car is not the only car. Like there are many other different cars that serves like different purposes. It also applies to AI. AI is not only for chat. Like there's so many different uses that AI can apply to. So like just expand your like understanding. And then what about like other industries that rely on auto usages, right? It's not just like auto manufacturers who create like automobiles and sell it. So one of the thing here is like public transit and bus. For those who don't have like their own private car, they ride the public transit and bus, sometimes for free or for like $1 or something. So I can see like those kind of things. Would it be like a Bing chat, Google Gen AI search, ChatGPT, or Gemini Basics that don't really charge like anything to you on the web? And when you see like a supply chains, shared mobility services and rentals, they can be compared to like a cloud AI services. And then when it comes to rentals, you can also think about the subscription-based AI services for now. But then let's compare which industry is bigger than the other in auto-related industry. So when I just checked the GM and Ford market cap, altogether it was like $93 billion. But when you see like a UPS and FedEx, whose primary services heavily rely on like automobiles and trucks and everything, right? Those together, their market cap was $200 billion. It was just like a double, right? So lesson here is car manufacturing sales generate a small fraction of the total business values associated with automobiles. Okay, then can we apply this learning to AI? So creating or improving AI capabilities seem like a big deal for now, because all the news you hear is like, oh, GPT-4 is better than GPT-3. Then you got Gemini, and Gemini can do this, that, etc., right? It sounds like a big deal, but it will be only a small fraction of total business values associated with application involving LLMs and AI. So like, that's my message, to persuade you to join this AI field. Okay, now, so what, right? So what? The industry is growing, so what? So the first message is, it's okay if you don't understand A to Z of AI models. Let me ask you a question back. How many of you know A to Z of computer chips or programming language? Right? Even though you don't know it, it's okay. You program software very well, right? The second message is like, all you need to understand now is what AI models do. In the very first page, I told you I broke down like a large language model into 3 pieces and explain like what they do with it. I think like that's pretty much enough. So let me ask a question back. Basic knowledge in computer parts and programming languages is what you need in most cases, right? Just basic knowledge, right? You don't need like advanced knowledge in those. You know like what is RAM, what is CPU, right? And how they communicate. That's pretty much it. And then the third message is find where values are and where your skills can be optimally leveraged. So you found your skills in software development. So why not AI? So let me give you an example of like one of the roles in logistics and shipping. So a position called supply chain analyst is to analyze the data and logistics to improve the supply chain efficiency. And one of their responsibilities is to balance supply and demand of material flows. Can we really like find like analogous like role in software developers? Right? This one in data is like balancing supply, demand, and flows of text, vision, audio, and video input and output of data. And some of you doing like a Kubernetes, or some of you doing some like microservices in like a cloud architecture. It really applies that, right? So like your skills and leverages are already like a very valuable skills in AI. So what should you do as your first step? So the first step is just like go to some like a documentation pages of like a well-known like packages like Hugging Face, and you can go to like OpenAI cookbook where people post how they use the LLMs and AI for now, and then just like go over their usages and try to replicate it. And I also got the Neil's LinkedIn post because it was like 3 months ago, and then like he just like tried the cloud API, and then like he just like wrote down like he's like learning from it. I think this is really critical because like just trying and not trying has so much difference at this like initial stage of like AI. So like just trying, you're already like ahead of so many people, right? So just try it and see like if you like it or not, right? Finally, here are some like useful resources. So Hugging Face is, so you can think of like, okay, so the AI is like a deep learning model. So do I need to know PyTorch? Do I need to know like a TensorFlow? Yes, but past 2 years it changed so much that knowing Hugging Face is actually enough. If you're just like applying AI, not really customizing, then Hugging Face really provides everything for you. And you can also, if you're using like OpenAI's ChatGPT API, then go to like OpenAI Cookbook. I also posted like learning from 2 database companies because like in the past presentation, I briefly introduced retrieval augmented generation, and knowing vector databases and how they work would give you some like knowledge in how to operate RAG. And then finally, there are so many YouTube videos you can watch. They explain better about AI than me, probably. So go visit their channels and watch the videos. Okay. So for those who not interested in AI research, you guys can feel free to go. But otherwise, yeah, I'll just keep continue. No one? All right, I'll keep going. Okay. So what are some like a foundational knowledge for AI research? I just broke down into like a three big principles, main like subject. So one is mathematics. I really, really want to emphasize the importance of linear algebra because like after okay, linear algebra is very important and matrix algebra is very important. And then you also need to understand probability because after all, it's predicting the next tokens or predicting like predicting something for a particular task. So probability is important. Numerical analysis gives you some understanding of how the numbers are calculated and how the matrices are decomposed in computer systems. And then statistics is another big pillar in this AI because you want to understand about the probability distribution of the outcomes because based on the distribution you have different loss function. And then you also want to know about the optimization or sometimes it's called like a learning and estimation. And what's the property of those like estimation as you have like a more samples or less samples or etc. And then you want to know about the MLE principle and convergence, and most important, I think like that's generalized linear models is very related to this like very early days of like a machine learning. So generalized linear models is important, and then mixed effect modeling is a new one I added like a month ago or something because mixtural AI they publish their own model with like small agents that works like a mixed effect model, or they pretty much introduce some ideas from like random effect in statistics. And lastly, in computer science, I'm not a computer science guy, so those are the things I understand from computer science. So I think like for people from mathematics and statistics, we need to understand object-oriented programming because typically we use like a programming as calculator, but the way you guys use are totally different. And to understand a little bit about it, we need to understand the object-oriented programming. And data structures and algorithms are important, and obviously deep learning training and inference gives better idea of how to train the model and evaluate. Good? All right, next one. This is gonna be really deep. Okay, so when it comes to linear algebra, like it's not just about like reading the textbook. You should like live in the linear space, right? So you are not reading the matrix as just like a full of numbers in table, but you're understanding matrix as a function or mapping. So you're basically converting a vector into another vector through that matrix multiplication. So you should understand what's happening through the funnel of the mapping, right? And there are some like a special matrices, like a symmetric matrix, rotation matrix, idempotent matrix, orthogonal matrix. Understand like a basic characteristic of those matrices because like they all like come out in the architecture at one point. And decomposition is also very important because like when it comes to LoRa, you probably hear about decomposition ideas. And then if you want to know about linear algebra, go to the MIT OpenCourseware and search for Dr. Strang's lectures and textbooks. They'll teach a lot. So if you want to know, just go to Dr. Strang's lectures and see if you can understand it. If you find yourself understanding what he talks about in the lectures, you have really high chance that you have talent. Seriously, like if you understand it, yeah, move on. And I just put the helpful resources for LLMs and AI. And yeah, those like websites and resources are very helpful. And I really want to highlight the second one, Natural Language Processing with Transformer. That book is very useful. If you already know about some like a deep learning, go check that second book out because they really talk about a lot of stuff in detail. And then here are some like a key archive papers. There are so many things. I just like put some like basics. The highlighted ones talk about the basic all-day models. For example, Transformer, BERT, GPT-2, and Vision Transformers. And then rest of them are talk about like some other different methods. So instead of like listing like hundreds of papers in here, it would be more useful to talk about how to properly read archive paper. So when you read archive paper, I think I spend most of my time on understanding introduction section mostly, because introduction section mostly talk about their rationale and background and how they ended up with doing such project. And knowing such context to give you better understanding of the method. And when relevant studies section is missing, the introduction mostly covers that relevant studies. So they give you some background knowledge to understand their research. And then if a paper is about a model, then I mostly go check out their GitHub repo if they provide it, and check like how they realize their idea into Python code or other programming code. And then not all papers deserve a summary. So like some papers you can just like skim through and get the idea and done, but some papers need like thorough summary to just like check it out later. So here's an example. I did a summary of archive paper, LLM Lingua. And as you see, like so the way I do it is like, I'm not like rewriting, I'm not paraphrasing their words, but I'm actually like rewriting some of the sentences that really captures the core messages. And then I sometimes like highlight the word because that's not what author does, but like I highlight the words, keywords with colors or like a bold font, so that like next time I read my own summary, I can just like pay attention to those pieces. And here's another summary of Laura. In that case, I just leave like several more messages that I think I understood better. So yeah. So that is it. But okay. All right. So I don't know how many of you are on the Slack channel, but in data science sub channel, one day I posted some like a one sentence summary of like some archive papers, and then like turned out it was just me just doing that, so I just stopped doing it. But
I was reading it for what it's worth.
okay, all right. So if you I don't know, if you have questions while reading archive paper and need some help in explanations, let me know. We can have like a brief chat to discuss about it. So that's pretty much it. Yep.